Well, Willie, what happens if we are dealing with rational exponents, but the numerator in the rational exponent is not a 1, but a 2, or some other number? For example, 1,000 to the 2/3. I know, what in the world does that mean? Well, what I can do is I can modify that rule that we had earlier. A to the 1 over n equals the nth root of a to the 1. Well, if we just make that an m, we'll make that an m over there. Yeah, I know. Why didn't we do that the first time? Well, we're just kind of breaking our way into the process. So I can rewrite 1,000 to the 2/3. That's hard to evaluate, but I might be able to evaluate it if it was in radical form. So this becomes the cube root of 1,000 squared. And look at that. Well, I don't know what 1,000 squared is, but I do know what the cube root of 1,000 is. And that's 10. So I have 10 and that square, and that equals 100. So 1,000 to the 2/3 is actually 100. Let's look at two more examples. 16 to the 3/2. So what are you thinking about 16 to the 3/2 here? Are you starting to see it? Can you visualize what I'm going to write? I'm going to write the square root of 16 to the 3rd. You know, this little 2 right there, square roots, if there's not an index on a square root, it's understood to be a square root, or the index is understood to be a 2. That's why a 2 really does belong there, but since they're so common, we've dropped it in this particular case and just assume it's a 2. So the square root of 16 is 4, and 4 cubed is 64. So 16 to the 3/2 evaluated is 64. All right, my last example here. Minus 32 to the 3/5. What do we do with that? Minus 32 to the 3/5. Well, let's rewrite that in radical form. So I have, well, notice too that this 3/5 only applies to that 32, not to the negative. The negative is not part of the base. So I have a negative, I have a 5th root of 32 to the 3rd power. Negative, the 5th root of 32 is a 2. And negative, again, that negative is outside of its base. So negative 2 to the 3rd is 8. So that evaluates to -8.